All right, welcome everyone. Today we are going to look at an introduction to the quadratic formula. So sometimes you'll be given the quadratic formula. We'll learn that in a video next week and told to memorize it and not really shown where it comes from. So the process of deriving the quadratic formula or finding out where it comes from is a little bit complicated, but I want to go through it with you so that I can kind of give you a clearer picture of why this formula exists and how we can use completing the square, one of our methods for solving, to find the quadratic formula. What we're going to start off with is just a general quadratic. Ax squared, so we have standard form, plus bx plus c equals 0. So here, standard form a, b, and c just represent real numbers. A, b, and c are just real numbers that we're working with. And we're going to complete the square to solve for x. So this is the method that we're using. We're trying to solve for x, and we're going to complete the square to solve for x. So to start off, we have this coefficient a in front of x squared. A could be 1, but a could also be not 1. When we complete the square, we want an x squared in the front here. So what we're going to do is divide everything by a so that we end up with that just 1x squared, a leading coefficient of 1. So x squared plus bx over a plus c over a equals 0 divided by anything is 0. And this is assuming we have a quadratic. If this isn't a quadratic, we'll be dividing by 0 here, which gives us an undefined value. So this doesn't work out. Okay, so we have a coefficient of 1. Next, we're going to look at our middle coefficient. Let's rewrite this as b over a times x plus c over a. All right, so here we take our middle coefficient. We're going to divide that by 2, b over a divided by 2, and we're squaring that. For the inside here, I can rewrite this as b over a times 1/2 instead of dividing by 2. And that makes it easier because we could just multiply the a and the 2 in the denominators, b over 2a squared. Okay, b over 2a squared. So this is our goal. For the constants place. So we want b over 2a squared, whatever number that is, to be in our constants place. So we want that in this spot. So what we can do is first, I'm going to subtract the constant that we already have. So subtract c over a from both sides to give us x squared plus b over a times x plus 0 equals negative c over a. And that way we end up with a 0 here, which means to reach our goal, we just have to add that b squared over 2a to both sides. So let's rewrite this too. Let's just go ahead and if we're squaring, we can square the numerator and denominator separately. So we have b squared over, we need to do 2 squared, so that's 4. And we need to square the a also. So 4a squared, b squared over 4a squared. So we're adding b squared over 4a squared, which is just the simplified version of our goal, b over 2a squared. And we're adding that to both sides, 4a squared. Okay, x squared plus b over a x plus b squared over 4a squared equals, on the right side, we have b squared over 4a squared, almost out of room, minus c over a. Okay, and this helps us out because we've now reached our goal for the constants place. The constants place is b squared over 4a squared, which we can see here is equal to our goal. And that goal is helpful when completing the square because we can now rewrite the left side as a perfect square. And the constant that we have in our perfect square is our middle coefficient divided by 2. So this value inside of here, which, as we saw when we simplified, is equal to b over 2a. So x plus b over 2a squared equals, and then on the right side we have all of this, the b squared over 4a squared. So we added this to get a perfect square on the left, and then we subtracted the c over a to make it easier to complete the square. Okay, so we have completed the square. So at this point, we completed the square. Cool, we have a perfect square on the left. And remember, our goal is to solve for x by completing the square. So at this step, what we can do, completing the square helps us out because we can then take the square root of both sides to try and isolate x. So let's go ahead and do that. We'll take the square root of both sides. X plus b over 2a. The square root cancels out our squared up here. Equals the square root of b squared over 4a squared minus c over a. Okay, and then finally, we are just adding something to x. And oops, I almost forgot. When we take a square root, we have to do plus or minus in front. Plus or minus square root. Okay, so finally, x is almost by itself. We just need to subtract this b over 2a from both sides. So negative b over 2a plus or minus the square root of all of that, b squared over 4a squared minus c over a. Okay, so we have solved for x. At this point, we have isolated x. But if you've seen the quadratic formula before, you might see that we aren't quite there. We aren't quite at the quadratic formula at this step. Although we've isolated x, this formula is still a little bit hard to work with. And all of that means is that we can rewrite the right side to kind of condense our terms. And that way we end up with fewer areas where we need to substitute our a, b, and c. So we're going to kind of clean up that right side and make it a little bit easier to work with. We can do that by looking at a few different parts. Let's first examine the inside of our square root. So we have b squared over 4a squared minus c over a. Now, it might help us to combine these. So we're subtracting fractions or adding fractions here. And in order to add fractions, end up with one fraction, we need a common denominator. So notice here we have a denominator of 4a squared. Here we have a denominator of a. So to end up with a common denominator, 4a squared, we need to take a and multiply it by 4 and another a. So I'm going to take c over a, multiply it by 4a. And we need to multiply this by 4a over 4a so that we multiply it by 1. So this doesn't change the value of our fraction. This gives us b squared over 4a squared minus c, 4a times c over 4 times a is 4a squared. And now we have that common denominator, which means we can go ahead and add or subtract the numerators. B squared minus 4ac over 4a squared. Okay, cool. So starting to look a little bit more familiar if you know the quadratic formula. Let's go ahead and rewrite our right side, negative b over 2a, plus or minus. And now we're writing this with one fraction inside of our square root, b squared minus 4ac over 4a squared. Finally, we have a square root and we have one fraction, which means we can take this square root and we can kind of apply it to the numerator and the denominator separately. So at this point, what I'm going to do is split up this term here. So let's look at this square root. Oops. Okay, let's look at the square root. B squared minus 4ac over 4a squared. We're going to split this up. Square root of b squared minus 4ac over square root of 4a squared. And then we end up with the numerator. If we're multiplying, we can take the square root of these separately. So square root of 4 times square root of a squared. And notice we have perfect squares in our denominator. So square root of 4 is 2. Square root of a squared is a. So we end up with this right term, with this square root, being able to rewrite this as negative b over 2a plus or minus this over here, plus or minus the square root of b squared minus 4ac all over 2a. And finally, looking at those two terms, notice we end up with a common denominator. So we can actually add or subtract the numerators of these and rewrite these as negative b plus or minus the square root of p squared minus 4ac all over 2a. And now we've reached the quadratic formula. So now we see the familiar quadratic formula, if you've seen it before. Cool. So we did isolate x up here, but we had quite a few places where we had to plug in our coefficients. We cleaned it up a little bit just to be one fraction over here. So negative b plus or minus the square root of b squared minus 4ac over 2a. So again, this process gets a little bit complicated because we're dealing with variables instead of numbers when completing the square. But all we did was we completed the square to start. So we found our goal. We added that to both sides, ended up with a perfect square, and then took the square root to isolate x. So we just completed the square to isolate x. And again, we started with ax squared plus bx plus c equals 0. And then once we isolated x, we did some simplifying. So we just combined our fractions by finding a common denominator to simplify the inside a little bit, and then took some square roots. So if you're curious, this is where the quadratic formula comes from. So this is a way to show that the quadratic formula is true, or show where we get it. So instead of just giving you the formula, here's kind of an explanation, which starts with a process we know, completing the square, and ends with a quick way, in some cases, a quick way to solve quadratics. And this can be used to solve any quadratic too.